Hello, welcome to a video. We're going to talk about the law of sines today. The law of sines is a really, really cool law that you can use in trigonometry. And we're going to talk about where it comes from and then also how to use it. What's neat about the law of sines is that you can use it on any triangle, not just right triangles. So we're going to solve this problem here using the law of sines in a moment. But before we do that, I wanted to show you where it comes from. Remember that in a previous lesson, we talked about how you can find the area of a triangle if you know the length of two sides and you know the angle that's between those two sides. And I won't get into all the reasons why. You can watch that video if you want, but you can find the area using this alternate area formula where A and B are the two sides that surround the angle, and then C is that angle. So you could find the area of this triangle by doing 1/2 times 18 times 39 times the sine of 125 degrees. We talked about that before, okay? But it's not, if you know all the angles, you have lots of options, right? And the reason you'll see why I'm showing you this in a moment, but let's just say this was a 23 degree angle. Well, that means I could find the area of this triangle using the side that's 39 and the side that's 51, because those are the sides that surround the 23 degree angle. So I could also do 1/2 times 39 times 51 times the sine of 23 degrees. And if I did this on a calculator, and if this were actually 23 degrees, then I would get the same answer. And I could do the same thing using this angle over here, but you get the point, right? You can use any two sides that surround any angle. And so what we looked at in class was this proof of the law of sines. If we take the area of this triangle, for instance, and I say, well, one way that we can represent that area is using this 1/2 times side B times side C times the sine of angle A, because angle A is between sides B and C. We can represent the area using sides A and C and then angle B, because B is the angle between sides A and C. And then, of course, the last one is the one that's sides A and B with sine of angle C. So these three expressions are the three different ways that we can represent the area of the triangle using the alternate area formula. Notice that well, anyway, since it's an equation, we can simplify this equation doing anything we want. So the first thing that I would do is just multiply by 2 so that we can cancel out the 1/2. And then we have BC times the sine of A equals AC times the sine of B equals AB times the sine of C. And then if you just divide everything by the same factor, which in our case is ABC, so you can cancel out a bunch of terms. The B's cancel and the C's cancel on the first one, and so on. And then if you eliminate those canceled factors, then what you're left with is the sine of an angle divided by the opposite side is equal to the sine of any other angle divided by its opposite side, because angle B is opposite of side B, and angle A is opposite of side A, and angle C is opposite of side B. So you get this proportional relationship, which is really neat because you can use it on any and every triangle. So let's now solve a problem with the law of sines. Remember that it's saying that the sine of an angle divided by the side that's opposite of that angle. So let's start with this 41 degree angle, and you can see that the side that's opposite of that 41 degree angle is 9 centimeters long. So I could start by saying the sine of 41 degrees divided by 9, okay, is going to be equal to well, the sine of another angle divided by its opposite side. And we happen to know that this angle is 68 degrees. And then the value that we're actually trying to find is the side that's opposite of the 68 degree angle. So the first thing we do with the law of sines is we just set up a proportion like this. So I know, again, that the sine of an angle divided by the opposite side is equal to the sine of any other angle divided by its opposite side. Now we have to solve this thing. And I'm going to remind you that when you have a proportion, two fractions that are equal, a great method for solving is to use the cross product. The numerator of one side, the product of the denominator of one side and the numerator of the other side. So in our case, 9 times the sine of 68 degrees will be equal to the other cross product, right? This denominator is x, and the numerator is the sine of 41 degrees. So I did the cross multiplication, and now the last step to get x by itself is to just divide both sides by this number that I can calculate, the sine of 41 degrees. And so now I've done everything all the algebra that I needed to do to isolate the x, and the rest of the work is just using a calculator. And you have to be pretty careful there, so I'll actually demonstrate that here in a moment. But x is going to be whatever, 9 times the sine of 68, and then I take that number and divide it by the sine of 41 degrees. And so let's use a calculator and calculate that. Okay, here's a calculator. I'm going to make sure that I'm in degree mode. And the first thing I'm supposed to do is the numerator is 9 times the sine of 68 degrees. So 9 times the sine of 68 degrees it's this number 8.34. You don't actually even have to write it down, but just as a note here, the numerator is approximately equal to 8.34. And then I'm supposed to divide that number by the sine of 41. So I just leave it in the calculator's menu like this and go divided by the sine of 41 degrees, see, and then bam. So it turns out that's about 12.72 centimeters is what we've calculated that to be, 12.72 centimeters, which seems to make sense if you look at this diagram. So there will be many assignments moving forward on which I want you to practice this, but you can always come back and watch this basic video of how to find a missing side using the law of sines. See you next time.